Welcome to Module 3, OpenNMS Events. Events are a central component of OpenNMS. This is a network monitoring application, and if nothing is happening, why monitor? Coverage includes the definition of events within OpenNMS, the event daemon, event configuration, and finally, event generation and observation. From now on, the directory /opt/OpenNMS will be referred to as OpenNMS Home. Events are covered in the OpenNMS operation documentation. Look under Deep Dive and then Events. This module will cover some, but not all, of the topics therein. Events are defined within OpenNMS per the documentation as structured historical records of things that happen in OpenNMS and the nodes, interfaces, and services it monitors. It is of note that the concise Oxford English Dictionary defines event as a thing that takes place, so it may be more precise to say OpenNMS handles externally or internally generated events. An internal event might be generated because of a threshold violation, such as disk usage exceeding some predetermined value. External events are generated by SNMP traps, syslog messages, the OpenNMS web admin send event web interface, or REST calls generated by the OpenNMS send event.pl command. The handling of events includes storage, display, forwarding, and/or suppression. At the heart of OpenNMS lies the event bus. Any OpenNMS component can publish events to the bus, and any component can subscribe to receive events published on the bus. The publish-subscribe model enables components to use events as mechanisms to send messages to each other. The OpenNMS process service component that handles events is called EventD, and the D at the end signifies that this is a daemon, a background process. It is one of the key OpenNMS services, and its status can be checked with the OpenNMS-v status command. EventD must be in the running state for OpenNMS to work. The configuration file that tells OpenNMS to run this service is OpenNMS home/etc/service-configuration.xml. Not a lot to see at this time. The method value is a method within EventD called at a particular point in the lifecycle of OpenNMS. The pass is an ordering. So, when OpenNMS starts, EventD in its course calls its init method, followed by its start method. When the status of OpenNMS is requested, EventD will call its status method. Finally, when OpenNMS stops, EventD will call its stop method. There are 3 configuration files related to EventD. The configuration files are located relative to OpenNMS home/etc. From the reference daemons EventD page, use eventd-configuration.xml to configure generic behavior of EventD. For example, you can set the listening TCP and UDP IP addresses and ports, or you can set a timeout on the TCP socket. The file eventconf.xml is the main configuration file for EventD. The files under Events with the XML extension are called event tributary files and define events in OpenNMS. These must be referenced as an include directive in eventconf.xml. These files define the events OpenNMS is configured for. Currently, OpenNMS is configured for 17,700 plus events. Before diving into the files, note that modifications to any OpenNMS configuration files are effective either automatically within a short period of time, through a reload event, usually specific to the service configuration being modified, or by restarting OpenNMS. OpenNMS must be restarted whenever EventD-configuration.xml is modified. There is a reload event available whenever eventconf.xml or any of the XML event tributary files are modified. EventD also has a log file under OpenNMS home/logs/eventd.log. EventD-configuration.xml uses TCP address and TCP port to define the EventD TCP socket connection parameters, and UDP address and UDP port to define the EventD UDP socket connection parameters. The default values limit access to EventD to the local host on port 5817. These values can be changed, but don't. There would definitely be a ripple effect through OpenNMS. Receivers is used to define the number of EventD threads running. GetNext event ID is an SQL query used to retrieve the value of the next event ID. This will be demonstrated in a moment. Socket SO timeout required determines whether or not a timeout is set on the EventD TCP socket. By default, no timeout is set. But if a timeout is set, then socket SO timeout period is set to that timeout. The value is in milliseconds. Begin in the OpenNMS home etc subdirectory. Print out the EventD-configuration.xml file. This is a bit confusing to look at, so display the file in a clearer fashion by using this sed command. It replaces each space in the file with a new line. This makes it a bit easier to see each of the attribute value pairs within the XML file. The TCP and UDP sockets configuration is the standard localhost and port 5817. The number of threads allocated to service event intake is set to 5. The query used to retrieve the ID of the next event is set to the SQL statement select next value event next ID. The TCP socket timeout is required and is set to 3 seconds. To validate the process to which port 5817 is attached, use the netstat/grep command given. Interpret this output in the following manner. A Java process with process ID of 5373 is listening on TCP port 5817 and open on UDP port 5817. And search for the process using the ps/grep command given. It is a Java JDK17 process using the jar file OpenNMS_bootstrap.jar. This is the OpenNMS main process. This process has a number of threads. To find the threads that may have something to do with EventD, use the ps-l grep awk command as given. The command lists the lightweight processes associated with the process 5373. The grep filters for threads with the word event in their name, and the awk counts the number of each such threads. Interestingly enough, the Event IPC Manager has a count of 5, matching the EventD-configuration.xml receiver attribute value. To see how the attribute getNextEventID is used, access the OpenNMS database using the PSQL command shown. Accessing PostgreSQL as the user OpenNMS will directly access the OpenNMS database. When accessing PostgreSQL from the same server that PostgreSQL is running on, it is best to use the localhost IP. The \d command lists all relations, tables, sequences, views, and so on in the OpenNMS database. Scroll down the list a bit to find 2 tables, event_parameters and events, and a sequence, events next ID, that are related to events. Use \d events to get a description of the events table. This will provide a list of columns in the events table. the value type, and constraints of each column. The primary key is EventID. EventID is not part of the incoming event notification. It is generated by OpenNMS to uniquely identify events. The event ID is determined from the event's next ID sequence. The sequence is the schema object that generates a sequence of numbers in ascending or descending order. The sequence is not associated with any table, but it can be used to populate data in the primary key or unique columns of a table. Here is the definition of the sequence event next ID. The value given for the maximum indicates that this OpenNMS database could receive 1 million events per second for the next 292,000 years. Notice that the event ID value is not able to cycle. By the way, if an OpenNMS service is getting 1 million events per second, something might need fixing. The current value of the sequence is found with a select clause. Remember, this is a current value. When the getNextEventID SQL statement is run, it should return a value 1 greater than that just found. It does. On a live system with a large number of events, things will probably not work out this cleanly, as the event counter is liable to change value rapidly. To get the max event ID value currently stored in the event table, run the SQL statement, select max event ID from events. This value may or may not equal the current value of the event's next ID sequence. That is because events can be removed automatically or manually in OpenNMS. Events can be viewed through the OpenNMS web page by clicking on Status, Events, All Events. Note the event ID in the far left column. Up next, Module 3 continues with more on event configuration.